without further ado, this is Heather Mallory. Heather's our program chair, and she's also our incumbent vice president. So I'm going to let her introduce Mr. Denver Holt.
Thanks, Ted. Good evening and welcome. Coeur d'Alene Audubon would like to introduce Denver Holt, one of the world's leading experts on owls. Denver is the founder and director of the Owl Research Institute in Charlo, Montana.
Good enough.
For more than 3 decades, Denver has dedicated his career to studying owls, especially the snowy owl and the long-eared owl, conducting groundbreaking field research that has expanded our understanding of owl ecology, behavior, and conservation. His work has taken him across the Arctic and around the world, and he is widely respected for his long-term research and commitment to protecting owl population and their habitats. So please join me in welcoming Denver to Coeur d'Alene.
Okay. All right. Thanks. Can you hear me okay back there? All right. Heather, thanks for making this happen. And thank you guys for all coming, and the Audubon. And, you know, a couple of you guys came over to our migration site the past 2 seasons over in Flathead Lake, Montana for our southern migration, and that kind of led to all of this and all that stuff. So anyway, what I'm going to do is I'm just going to kind of bring you through a year, more or less, of the snowy owl. Our research has been going on for a long time, have a lot of cool information, but put it together, you know, for an evening slideshow is a little difficult. But so it's a balance. You know, you have a popular group like you guys, and so you got to show a lot of pictures with a little data. And then when you go to another group, you got to show a lot of data with the little pictures. And so finding them from the middle ground is difficult sometimes. So anyway, I think I'm better off up here. All right. Okay. So that way I can be closer to the screen and see what I want to say. So anyway, you can see here it's been going on for a long time. I think I believe June 10th, it'll be the 36th year or something like that. So long-term studies. Okay, just quick highlights here. You know, 35 years of breeding, 30 years of lemming sampling, 100 square mile study area, 300 nests plus found, 800 owls banded, first snowy owls in the world with a satellite transmitter. So everyone's familiar with all that. Well, the first owl in the world, we put the first 6 satellite transmitters on. Only live cameras ever in the world have been at our study site in Barrow, Alaska. So if they're breeding this year, there'll be a live cam. And you can go to our website and see live cams on great grays right now, burrowing owls, and a few other things. And then, of course, the snowy owl. There's no other bird in the Arctic that is the icon of the Arctic for birds, like the polar bear is for ice and all that. So anyway, just some quick highlights there. This is our study area up in Utqiagvik or Barrow, Alaska. These are some other study areas around the world. Only one other study area, really. Wrangel Island, Russia, has got, you know, longitudinal research like ours. I think Irina worked on hers for about 30 years or so. And then there's some pieces, you know, here and there where people are able to put years together to get some kind of long-term data. But the 2 really most detailed ones are from Wrangel Island, Russia, and Utqiagvik. Now, Utqiagvik used to be called Ukpiagvik. Not long story there, but Ukpiagvik meant a place to hunt snowy owls. In the Inupiat Eskimo culture, the snowy owl is called Ukpik. And I've been around long enough up there, and now I'm called Ukpik man by the Inupiats. But anyhow, so that's just shows you a little area of where they occur. And this just kind of shows you our 100 square mile study area, more or less. I'm not going to do it in kilometers. But that's it, and these just show a number of nests and where they're located. This is what it looks like. This is July. This is Barrow or Utqiagvik, Eskimo village. And it's right along the Chukchi and the Beaufort Seas up in here. And it's a migration route for whales and a lot of marine mammals. It's primarily a subsistence culture where they kill and eat whales and marine mammals and seals and things like that. Do some fishing and all that. But it's kind of a rough place. You know, tough place to make a living, but the Inupiats have been able to do that. The snowy owl, now, in Inupiat Eskimo culture, Usually the animals that they admire are the ones that they kill and eat, that they hunt for subsistence. So they get a lot of carvings and stuff. The snowy owl and a few other species of birds usually aren't carved, but for some reason the snowy owl is really admired by the Inupiat people. Now they used to kill them and eat them during the summertime. They used to take their eggs, harvest, not all of them, but harvest some eggs from the nest and eat their eggs. They used to take the chicks out of the nest and raise them as pets, and when they got too unruly, they just throw them back on the tundra, and good luck. But, so this is Tommy Coates, and this here is a piece of walrus ivory, and you can see here, this is fresh ivory here, and then the eyes, the yellow here is fossilized ivory, and then the black here is baleen from the bowhead whale. And these are the types of, trinkets, whatever, carvings that the Inupiats carve for snowy owls. So they've been around a long time. This is what it looks like when snowy owls come back to the breeding ground. So it's kind of an interesting place. And if you look out in here, you'll see mounds. And these mounds, and you'll see, we'll get to it later, but as spring comes and the sun stays up longer and the wind keeps blowing, there's less snow on those mounds. They melt off first, and when the owls come back during spring up there in that spring, then they'll seek out these mounds that melt off first as their nest mounds. Let's see if this works here now. That's a ground blizzard. I have no idea where I was going. And so we're just, but the thing to keep in mind is when the owls come back and they see that, what are they thinking? I mean, how am I going to evaluate whether it's a good lemming year or a bad lemming year? Where am I going to nest and all that stuff there? So anyway, a lot goes through the owl's minds that we don't really know. Okay, but it does melt off fairly fast with 24 hours of light starting in May or so. And what we're doing is we're looking for these mounds, and we're looking for white vertical postures or owls on mounds. All right, so once we see a white animal in the distance, adult male snowy owl, remember adult male snowy owl, then we look left and right, 500 yards to the left, 500 yards to the right, and we're searching for a female on a horizontal posture. So first we're looking for the vertical posture, and then we're looking for a horizontal posture on a mound, and hopefully that would be a female on a nest. As it melts off, it gets easier and easier to find the birds. And this is your typical adult male snowy owl, almost pure white. There are younger ones, and we'll talk about that later, that look like females that don't get to breed. And so we're looking for any evidence that the owls are breeding. So females are always screaming for food, if they're going to accept this male. And males have to deliver or else they don't get to breed. So females are maybe chasing males. We'll look at a male flying in. If he's flying around with a lemming in his mouth, we know something's up. He's feeding the female probably on a nest. But very often they'll come off the nest and chase him because they want their food. And so, females scream, males hunt. But this is ultimately what we're looking for. So we're looking for that horizontal posture, as I told you. And there she is. She's on her nest mount here. She's got a lemming. And she's just sitting there on eggs. And again, she's the sole incubator, she's the sole brooder of the chicks, and the male provides the food. Okay, now, one of the things we learned early on here, if I don't fall off this edge, one of the things we learned early on, now think of this here. She's got a commanding view. She's on a mound that's about 3 feet tall, let's say, and she's got a commanding view of the surrounding countryside here. But she's a ground nester. Even though she's big and she's powerful, she's a ground nester, so she's susceptible to mammalian predators, for example. So we have foxes out there, we have polar bears, we have some areas you have wolverines and wolves and other things running around, even red foxes these days. So anyway, she's constantly vigilant, and you can't think of sleep the way we think of sleep. And we've looked at that in these guys here. It's like they never sleep. They're constantly vigilant. So we noticed when we first started doing this, we would find our vertical male, find a horizontal female, and like, oh, we got this. This is easy, And you'd head out there, and we couldn't find the female. And we're like, well, God, I swear there was a nest out here. But we'd look over there, and there was a female over there, and there was a male over there, but there was no nest. So anyway, what we figured out after the first year or so was that here she is on a nest. Here she is, she's got the commanding view of the tundra. And so when she sees potential threats coming, like a researcher, for example, or it could be a fox, or it could be, all kinds of things, but, mammalian type of things, the first line of nest defense is for her to slip off the nest, all right? There's maybe 270 species of owls in the world. No other owl in the world does this, It's the only one that does it. But if you think about it, look at where it's sitting. It's on a tundra. The trees are only that tall. All right, there's nothing there to hide you, and you're basically white. So anyway, she'll flush off the nest. This is one of our females, and you can see her. She's marked here. She's got a band right there. She'll flush off the nest as the first line of nest defense. So we're like, okay, that makes enough sense. So we started measuring over the years. And they're like, okay, if we want to say that this is the first line of nest defense, then we have to make some comparisons with non-nesters. Because the males engage in nest defense, we couldn't do the breeding males, so you have to do non-breeding females and non-breeding males. So anyway, after doing a number of trials and all that stuff there, long story is the average distance that the female flushes off the nest, that's over 3 football fields, all right? That's how far away they're detecting a potential threat coming to them, and they slip off the nest so you don't find the nest. We learned how to do it just by seeing their breast feathers and stuff that were scattered around. And then we went to non-breeding males and non-breeding females. All right, so non-breeding females, they let us get pretty close. Non-breeding males let us get pretty close. So we have data to argue that they're flushing off the nest as the first line of nest defense, so you won't find the nest. So it's pretty good. We got some really good samples on that. All right, then, however, as I told you, we can't measure breeding males because once you narrow in on the nest, if you walk sideways like this, then it's okay. We do this every day with all the species of owls that we work with. We walk sideways until we want to really get something, then we turn on them. All right, so if you walk sideways, they won't flush. As soon as you beeline to them, they see that. They know you're coming right at them. So the females get off. Next thing is you get closer and closer, then the male engages. All right? So the male will come in. He may fly around like this and bark at us. Go, arr, 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 or hoot, ooh, ooh, ooh. So she's over here. He's doing hit. And this thing is so cool about the male and female snowy owls is there's a division of labor. Boys have their job. Girls have their job. And then they overlap for certain things. So anyway, so the male comes in now and he barks at you, or he hoots at you. The female lands and she's showing you some kind of distraction display. Hey, look at me, look at me, look at me. Or she may fake injury like a killdeer. All right, follow me, follow me, follow me, and move out to the side like that. Again, just trying to get us away from her chicks, all right? They may come in, if we don't leave, they may come in and kind of, threaten you, let's say. I mean, they're not going to really hurt us that bad, I don't think. But they come in and threaten you, try to drive you away. Or they may come in and attack. And so we go from probably the lowest form of nest defense is flushing off the nest to increased aggression, what we would say, with this being the highlight of nest defense, and that's the attack. All right, so let me see, hold on. It's hard to find these things. This is what it looks like here. I got to tell you, those legs are much longer than you think, all right? I've been hit so many times, and the first time I was like, yeah, I'll just duck, but boom, right in the head, boom in the back, etc. So yeah, those legs are really, really long. But this is what it looks like. Look at the concentration. So it is a community up there, so people have pets. And this woman has 2, 60, 70-pound black labs. She was walking down the road. The nest is 500 meters away. The owls hate canids, all right? They hate wolves, they hate coyotes, they hate foxes, anything like that they hate. So this male came all the way across, 500 meters across the tundra there, to whack these 2 dogs. Well, it hit the first dog, and he ran back and went underneath the truck. Second dog figures, I'll take on the owl. The owl came in, hit him again. The second dog went under the truck, and he drove him off. All right. And this, of course, it's the same thing. You see these giant chimpanzees or like us walking around the tundra out there. And this is what it's like when they come in on us. So there's a nest right here. There's a chick right here. And we have business to do with the nest. So we have licenses to harass wildlife. What we try to do it the best that we can, get in and out, gather data, and yet let them get back to work. So anyway, this male was particularly aggressive. He almost got my face, actually. But this poor guy, this is a climate researcher. So we always laugh because we're the wildlife people and they're the climate people, so they're not used to stuff like this, right? But he wanted to come out there, and he was from Costa Rica, Paulo, and so he came out with this brand new that day Patagonia coat, and the owls, that's not blood, but that's the pattern. And the owls just kind of ripped his coat apart. He said, "Look what I did to my coat." So anyway, so this is nest defense. But what's so neat is that they're so forgiving. So right after we harass them, we go in there and, whatever we're doing for, the objectives of the day. As soon as we leave, boom, she's right back on. Boom, he's right back to hunting. It's just like whatever it was, we drove it off, now we got things to do. Okay. This is what, so Liberty was our director. She wanted to go so bad. I want to see them because she never really did field work. She kind of ran the show. And I brought her up for field work, and this is what happened, is she wouldn't go to another nest after this, Yeah, and she's a cowgirl, she's a tough cowgirl. And she just said, forget that, All right, now this is just a frequency chart, and so it's got some biases in it, but nonetheless, the idea is to show you when I talk about males and females come together and have certain responsibilities and overlapping responsibilities. So you can just see here, male blue, female red. So both of them bark, ah, ah, ah. All right, males hoot, ooh. Females rarely do. Females scream. If someone wants to give it a little girl scream, that would be great. All right, males rarely do. Both attack, but this is a little biased because the one female attacked quite a bit. And then females display, males rarely do. So there are different things that the pair engages in order to help raise a family. All right, now think about this. If you were looking out on the tundra, would you really see a white little spot like that sitting out there? This is how difficult it can be when the tundra's melting off. But again, once we load and we're keyed into it, then we follow in with our work. So the female, she digs a little bowl. Now underneath here, 20 inches underneath is permafrost. It goes down hundreds and hundreds of feet. So we wonder, this is kind of interesting, we haven't proved it, but we wonder if the female doesn't sit on the ground at first and incubate the ground and warm it up, because then she has to dig. So she digs with her feet and pulls with her bill, and she creates a little 10-inch circle bowl where she lays the eggs and only she incubates. Okay, and then there's hormonal changes, all right? So there's increase in estrogen, prolactin, and other breeding hormones, and her feathers fall out, and she has one enormous brood patch. Then there's an increase in blood flow, and so she can regulate the temperature. She keeps it about 100 degrees Fahrenheit or so to incubate the eggs. But a huge, huge brood patch. But think of this. They can lay 3 to 10 eggs. So 10 eggs is a big area to cover, and she has this massive brood patch, and it's kind of flappy, I guess you would say there, and it kind of rolls over the top of all the eggs, and she can incubate. And so we do things like measure the eggs, and then we look at the chicks, and so here's one hatching out here, and you can see it. Here's the egg tooth. So inside, we can pick an egg up, and you can hear them go, and they just are pounding up like that. Most birds have a well-developed muscle in the back of the neck here, and then they pound themselves out. Once we see a little fracture in the egg, it takes about a day for the chick to hatch out. So anyway, they hatch out, the eyes are sealed shut, they can't thermoregulate, they're totally dependent on the female for food, warmth, protection, etc. It's a very, very slow developmental process. They tend to hatch out in the order in which they were laid. So if you have 10 eggs in a clutch there, first one hatches, maybe 10, 12 days later, the last one hatches, so you get that asynchronous growth. All right, so you have a big chick like this and a little chick that just came out of the nest, as in most species of owls. All right, so anyway, we monitor everything, and waiting them to open their eyes. We've got some good, really good paper on this stuff here on growth and development in snowy owls. But again, highly dependent on the females, but they grow super fast. They go from that white prototile first down into what we call the second or mesotile down. And that's kind of like the thermal down. That's the one you pick it up and it's so warm. Most owl species go through that as far as we know. Usually it's more camouflage oriented, but in this case here, we think it has camouflage and thermal function because it's super, super warm. All right, and this is what asynchronous growth kind of looks like here. You've got something about 2 weeks old here and scaling down 2 weeks, 12, 10, 7 or 8 days or something like that for those that are living. All right, and this is kind of cool too. So because they nest in the ground, you got to get off the ground. You got to get out fast because you've got mammalian predators out there. So most of their body mass is the last week. They leave the nest on foot at 3 weeks of age. This is weeks and weeks before they can fly. And they put on most of their body mass right in here just before leaving the nest. Because what happens after they leave the nest, you're susceptible to predators. All right, so you got to have that growth. And you could have Arctic foxes, and you can no longer hide under your mother's armpits. I should have said that first. You can no longer get in, hey, Mom, I'm freezing, and crawl up under there. Can't do it. Now you've left the nest. So these are what they face is Arctic fox, but the owls are tough on the foxes. They beat the heck out of the foxes. But the foxes still try to get a chick, and it might get one from time to time. Polar bears you can't do anything about if you're an owl, but you can still hit them. So they'll go in and they'll whack them. We've seen them whack caribou. All they're trying to do is redirect their path. So if the polar bear is kind of lumbering towards a nest or a caribou, the owl comes in, whacks it, whacks it. And then it's just, the bears or the caribou are like, shoot, and they just may go this way instead. And that's all they need to do. All right, so anyway. All right, and then they get harassed all the time by Jaegers. So there's 3 species of Jaegers up there, but the Jaegers nest close to the owls, and whenever the owls move, the Jaegers, everything hates the owls because the owls kill them and eat their children. And so the Jaegers are always chasing. Every once in a while, a snowy owl will get one, but it doesn't happen very often where he'll be able to rake the belly and grab the Jaeger. This is just nest defense of the Jaegers coming in for attacks. So there's a lot going on up there for a snowy owl. Life is difficult. Okay, so anyway, going back to what I kind of said here. Here we are at the nest here. And so the chicks are getting a little older. By about 15, 17 days, we know every individual because we monitor them every 3 days. And they all get banded because we know they're going to leave basically in order when they're about 3 weeks old and just go out on the tundra and wander around and scream for food. All right, so they all get marked. And so they came to the question, well, why leave at 3 weeks old? So one of my friends is a corticosterone research guy, stress guy, out of Tufts University. He came up and said, well, I wonder if they're stressed out when they're leaving the nest, Why do they leave the nest at 3 weeks of age? Is it a food thing? Is it big sibs beating up on little sibs? And so little sibs maybe leave first, I don't know, or big sibs leaving first. We don't know, but why do they leave? So we looked at their corticosterone, their stress levels. Is there a stressful event causing them to leave? So it's the hypothalamus, pituitary, adrenal axis this all happens to a stressful stimulus. If we bleed them within 3 minutes, all right, within 3 minutes, if we bleed them within 3 minutes, we get the basal level. Even though there's an instant flight or flight response to a potential threat, like you almost get in a car wreck, boom, you're on high alert just for that second there. And there's an instant response. It still takes 3 to 5 minutes to register in the blood, so you can get their basal level before stressful stimulus. All right, so anyway, long story short, we looked at on the nest and off the nest, and it's the same. Basically the same. There's some changes as they get a little older out here, but it's basically the same. So we conclude, and Michael's, he's the endocrinologist, we conclude that they're not leaving the nest due to a stressful situation. We could control for food and all that. And we just think they're leaving the nest because they nest on the ground. And they got to get out of there before a potential predator might come and get them. All right, and the asynchronous hatching is kind of interesting there. So maybe chicks 1, 2, and 3 get out of the nest, and 4, 5, and 6 don't, and the fox comes by and gets them. You still have a chance for sexual reproduction because they're out. Why it takes 3 weeks, where in a shorter owl it's only like 2 weeks to leave the nest, another ground nester, because they're such a big owl, and it's probably a developmental process. They have to get big enough before they can actually leave the nest. So anyway, that's what we think is going on. It's like an anti-predator thing. But anyway, they're cool, calm, collected out on the tundra there, and we continue to monitor them. And we get body weights, we're in survival data. Remember, they're all marked, so we know every individual, and we can tell you what's going on here. And we're just chasing them around the tundra. Some live, and sometimes we see signs that some aren't doing very well. It's not our job to make more. I mean, for all you rehabbers, it kills us to watch them die. But our job is not to make more. Our job is not to save them, except maybe on rare occasion if we cause something. Our job is to find out who lives, who dies, and why. All right, so anyway, so we follow them if they're sick, and some die. And then we try to take them in, and we do the gross necropsies, and then we can send certain body parts down for the histopaths. Mostly they die of starvation. You kill the parents, which happens from time to time, then all the chicks starve. And we can look at it too. And then other chicks just die in general, particularly the younger ones. And you look, their stomachs are empty, all the fat around their heart's been used up, and they show signs of hypothermia, et cetera. But some live, and now they're starting to develop, and they're pretty cool looking now. And so, they're probably one of the best looking birds in the world. I mean, there's no doubt about that. And so some live. They're all banded. We know individuals. Again, we're monitoring every 3 days, monitoring their life. Okay, and then when they start to get 30 plus days, 35 days or so, we start to see some differences in siblings. This sibling's kind of a lighter gray. This sibling's kind of a darker gray. This sibling's got some spots and bars, but not as many as this sibling here. And so as they develop, we start to see this in the sibs. Some of the sibs look like this. Some of the sibs look like that. So we say, okay, this has to be female and this has to be a male. But how can we quantify that and how can we prove that? So what we did, first of all, is we took blood and then we looked at individual feathers and we looked at all the markings on the feathers, and it was time consuming, and so we have what we call transverse bars, and those are the ones that just come across from the edge of the feather through the rachis or the shaft here, from vein to vein. And then you have irregular bars that still touch the rachis right in here, and some touch the vein, some don't. And then you have what we call spots, more or less, where they just are isolated little markings here that don't touch the feather rachis. So we took 140 birds, we looked at these characteristics, we collected blood, we sent blood into the lab. We didn't tell the geneticists our predictions because we figured that we would bias it and they wouldn't tell us the truth. And so anyway, that was the control, even though it's only a single control, right? And so we could be lying, but we're not. And so anyway, long story short, when we do it here, you just can look at one feather. If it has spots on either side of the shaft, it's a male. And if it doesn't have spots, if it touches right, it's a female. So we got all 140 correct from our field work, and the model got like 98% correct. So, but by just looking at one feather, and a lot of people are doing that now. Okay, anyway, I mean, look at that. I mean, that's pretty cool looking. I mean, that's about as handsome as bird as there is. And so anyway, we just chase them around. Meanwhile, this is kind of funny. Meanwhile, you know, because of the way we think as researcher types, well, we have to measure the nest mounds that they have and compare that with the random set of mounds to see if they're really selecting, you know, the tallest mounds that melt off first in the spring. And so when we do that, and the Eskimos, my friends, they say, hey, Denver, tell us something we don't know. They say, everybody knows they nest on the tallest mounds that melt off first in the spring. So there's a little bit of fun going on in there as well. And sure enough, you know, we do all the math and all that. But this is what's kind of cool about it, is that you just think of your roads here. And I don't know, where I live over in the Mission Valley near Flathead Lake, you know, we have lousy roads in the wintertime, you know, they freeze and they break open and then the ice wedges go inside and they pop up and they make for just lousy roads. It's the same thing on the tundra. You get minus 20 degrees and the tensile strength of the soil of the tundra starts to crack and open up. Then in the spring, the water goes down in there, and then come fall, winter again, it creates ice wedges which build up the mounds. And so eventually, what happens here is the mounds, a little crack, big crack, and you know on the roads around here, maybe in the wintertime, eventually you just got these big mounds and these broken roads everywhere. It's the same thing on the tundra, and it's like thousands and thousands of years that it takes to get those tall 3-foot mounds. So it's like old growth mounds versus old growth forest is what really is going on there. Anyhow, this is all the math about it. Yeah, the Eskimos were right. They said they nest on the tallest mounds. All right. And so anyway, and then, you know, this is a big female here, and so we're interested in looking at their travels and all that stuff there. So the first owls in the world, the first 6, I put satellite transmitters on with help. And so anyway, we tracked them. This is a female here. This is what it was like back then. The technology is much better now. And they're like, I mean, there's a zillion snowy owls flying around with transmitters on. It's kind of interesting. But anyhow, these are the first ones, and which led to what it is today. And they left Barrow up here, and then they went down here and went across Russia, across the Bering, went over here, back over here, back over here. Did a lot of movement. And you had to make interpretations, okay? And the incubation period, the nesting period, this and that. You can say, maybe it nested, maybe it didn't. Looks like this one could have nested, looks like this one maybe did not. So it kind of led to all the studies that are going on now. But the other thing was so cool was that they never went south. They stayed in the Arctic all winter long. All right? Now, native peoples knew that, and so when, we always like to say, we just discovered this, and all that. But if you talk to the people who live in the Arctic, they say, oh yeah, Ukpik's here all winter long some places. Ukpik goes out onto the ice and hunts the plinias, the open water, and kills eider ducks and sea ducks and things of that sort. So anyway, this is what led to what's going on now with all that. This is your typical adult male. They have a little bit of spots there, but almost a fluorescent white. And what they do is hunt. All right, that's their job. They hunt and they protect. The female broods and protects the nestlings. This is the weaponry. Yeah, I mean, it's big. It's as big as my hand here. I mean, that's my hand. So I've had those in my head and back and butt and everywhere else. So anyway, that's what it's like. I mean, it's got to hurt if you're a little lemming that weighs, 2 ounces or so. And that's the female or the male coming in with the lemming. All right, they eat weasels and stuff up there. And for you birders, their favorite bird, even though there's not many of them, is red phalaropes. So red phalaropes, they just must be easy to catch. They're plump little birds, and they're always spinning around and concentrated on whatever they can spin up from the bottom and all that, and the owls nab them. But this is a chick swallowing a whole red phalarope down. They eat eider ducks, so it kind of bothers the Fish and Wildlife Service because it's the Steller's eye is a threatened species, so the owls don't care, and so they eat them. They eat spectacled eiders. And for those of you who know birds, I mean, you're talking about a huge, heavy duck. And this female came off the nest. Dan watched it. He got this photo. It's one of the great wildlife photos, I think. And he could only see an argument going on or a fight going on, and she barely could fly, but she brought that duck back to the nest. A big, huge male spectacled eider. Fed on it for a couple days. All right, and then other things happen too, which you think, ooh, I don't know if I like this. But you got to think about this. Sometimes the lemming populations crash, all right? And the birds, the chicks in particular, are starving in the nest. So some die. And it's usually the smaller ones that die. They get just outcompeted for food. They don't get beat up or anything like that. They're just stronger. They can get the food when the male brings it in or the female brings it in. And so those chicks that die, sometimes they're just left there to dead. Other times the female eats them. Other times she'll feed a dead chick to her chicks. And you got to look at it from her perspective. I mean, she's trying to raise a family here. Times are tough. And there's a dead one here. This one's not going to do anything. I'm going to feed it to this chick, and maybe it gives this chick a chance to survive. And they eat lemmings. So this is the collared lemming. This is the one that turns white in wintertime, Kilimuratarik. All right. And then this is the brown lemming that doesn't turn white in the wintertime. But this is what makes the whole tundra go round and round up there, is the brown lemming. So just think of this. You're alive, and you're dead, and you're eaten. You're a pellet, and then you're analyzed by researchers, okay? So if we look at this, so this is a pretty good sample size here. This is the longest, most detailed study of snow owls in the world, I mean, hands down. And so, but if you just look at it here, if you look at pellets, all right, so this is just from pellets, you have a sample of 43,000. People say, Denver, you think your sample size is big enough? But I want it to stand the test of time, all right? So it will. And of that, 95% is lemmings. That's from pellets. So people say, all right, well, how do you know you're not biased? By just doing pellets. And so, okay, we got data for that too. All right, we did the indices. These are just the breadth of food you eat. What this means, very simply, you do a lot of these equations, blah, blah, and you come out with what's important. Well, if you look at pellets, there's really only one species that's important. It's a very, very narrow feeding. It's like a specialist, obligate lemming predators. All right. Then, this is what it looks like here. Okay, there's some dead lemmings in the nest, and these are the chicks and all that. All right? Yeah, and they're placed the way that the male brings them in, the female places them like that. So then if we look at caches, the critics said, well, yeah, you're not looking at what's in the nest. I go, oh, yeah, we are. And so we've got 3,000 plus prey in the nest, and it's still 88% is brown lemmings. You put the collared lemming in, still 90% lemmings. You get a few more bird species because you can identify them in the nest as carcasses, and so your niche breadth will broaden out a little bit. Basically, you're still only eating really one species for the most part, even though it looks like maybe two things are important in your life. Birds a little bit, but mostly it's lemmings. Lemmings drive the system. There's 56 lemmings piled up at this nest here. All right, and so it's really kind of cool because it's free data. You know, we realized it shortly after we started doing the study. Wait a minute, these guys are giving us free info. All right? I mean, we can get, now by going to the nest and counting these things and weighing them, we can get all kinds of information. We get their body mass. We can look at their reproduction. Are they scrotal males? Are they breeding females? Are they lactating? Are they swollen nipples? And we can get sex ratio information, body mass, and relative age. I mean, free information that no one's ever been able to get, but we were just lucky because the owls provided it. All right, so just hang with me here. So out of all 19 seasons where they bred, of all the caches and nests, the average, all right, the mean is 75 grams. So, and you got a sample size of 2,500 plus. I mean, that's a pretty good sample, okay? All right, so remember that. Then we have our sampling line, which is our trap line, where we sample the lemmings to try to get an index of what the lemming populations are doing over time, all right? And then we count nests, lemming nests from the winter, and we count lemmings, and this is all along transects. All right, so from our trap lines, you're at 44 grams, okay? If our trap lines are indicative of what's out there in the population, which over 19 years and thousands of samples in a range from 19 to 20 grams to 120 grams, we do believe that we have a really good handle on what's actually out there. So now let's look at this here, all right? So your brown lemmings cached, 75 grams, big sample. Your brown lemmings snap trapped, 44 grams, big sample. Sex ratio is about the same, but the differences up here and here are indicating to us that maybe the males are bringing their females, just the biggest ones. We don't know what they're doing with the smallest ones, but it buttresses our argument that the males, these wonderful guys out there hunting all the time for their family, not only are they hunting for the family, protecting the family, but I have a choice of getting that little thing there for you or that big one. I'm going to get that big one and bring the big one to you because that's going to be better for you and the kids, is what it comes down to. So that's what you think is going on, and the data buttresses that. And that's what a big fat lemming looks like. They're kind of hamsterish, if people don't know what a lemming is. So I got to digress here. Okay, so I used to work for Massachusetts Audubon Society. I was young and all that stuff back then. And they have, a call-in desk where you can say, report your bird sightings. And so I walked in the office one day, and whoever was working, hey, Denver, some lady called and said, there's a bunch of snowy owls up at Plum Island. And I go, oh, that's cool. And she said, yeah. And she asked me why they were there. And the woman said, so I told her that, usually when the lemming populations decrease or crash in the north, the owls move south, looking for food. And the woman thought for me, she goes, I didn't know citrus fruit grew that far north. Lemmings. So that's true. That's a true story. Okay. All right, so how are they doing? All right, this is the female getting back on her nest here after we disturb her. All right, so this is just, we got more data, one more year. But this is the nest from 91 to 2024. And you can see the populations clearly fluctuate. I don't believe in cycles anymore, and we can go into it or not, doesn't matter. But I don't believe in cycles, but definitely population fluctuations. And so, 33, 54, you can see until you get to about here, right, and then all of a sudden, boom, the last bunch of years, and we had 0 nests last year. So something happened after like 2014. I don't know the answer. The default answer is always climate change, but, I don't know. I don't think it's that simple. But anyhow, but here's the other thing that's important, all right? If you only study something, and I don't mean to offend anyone, for 1 to 3 seasons, typical graduate study, then you can't get really good information, unfortunately. And so if I study them, like right in here, it's, oh yeah, good year, bad year, good year, bad year. If I study them over here, oh my gosh, there's no snowy owls, I might make a different conclusion. If I study them over here, I'd say high, low, high, low. How cyclic is that? If I study them continuously for 35 years, I'd say population is doing good till about here, and then all of a sudden it fell off. So the long-term data, not many people do it. It's hard to get, it's hard to stay with it, it's hard to get funding for it. But that's what's going to stand the test of time. That's going to be the textbook stuff. It's not going to be the little snapshot stuff that we're so used to seeing. So, and I'm going to make another comparison here. This is our long-eared owl study with 35 years of data as well. And you can see here, if I was to study them in these couple years here, I'd say, oh, there's plenty of them. If I study them over here, I might say, oh, we're not finding them. But if I study them over 20 or 35 years, I would say populations fluctuate, but overall they're doing okay. Again, the need for long-term research, and it's just not what we do, for the most part, with exception. All right, how are lemmings doing and owls? Okay, this is what it looks like, is they're very highly correlated. We have a high number of owls and we have a high number of lemmings. It's a pretty good fit throughout, and we've got all the math on that there. So it's a pretty good fit. When there's a lot of lemmings, there's a lot of owls. When there's few lemmings, there's few owls. Some people say lemmings are doing fine throughout the circumpolar region of the Arctic. Yet other people say, well, lemmings in my area are going down, and the owls have disappeared, the stoats have disappeared, the foxes have disappeared, the Jaegers have disappeared, all as the lemmings. So some people think lemming cycles, if you believe in cycles, have crashed or have changed, and consequently, in those areas, the whole ecosystem is being affected by it. Clearly in Barrow, where we work, there's population fluctuations, and everything has a good year when the lemmings have a good year. The ducks have a good year. The shorebirds have a good year because everything's eating lemmings, all right? And so there's no egg predation on shorebirds, no egg predation on ducks. Even the cranes have a good year. The cranes and the gulls, they all eat lemmings as well. So lemmings drive the system in this area here. All right, so this just shows you kind of the distribution of the nests. And what we were thinking, well, what's nearest neighbor distance? And so anyway, long story here. If you just look at this here, this is the big take home right here. Nests are randomly distributed over 18 seasons. We had to throw one season out because we only have a sample of one. If we looked at the data and just did 1 or 2 seasons, and I was, a researcher that was doing 1-2 seasons for a graduate study or something like that, I'd say, oh yeah, nests are randomly placed throughout. But if we look at all the nests over 18 seasons, we have a different story. We start to see significant groupings. All right? These areas are always occupied. So again, going back to the long-term data set and large sample sizes, and this is what it looks like. This tends to be the sites always of these high, what we call high-centered polygons or drier sites. This is where the owls nest. This is where the highest densities of lemmings occur, according to our trapping. And so over time, it may not be the same mound every year. It could be a different mound within this complex here, but it's the same general area over time. So are the owls picking the site because of the nests, or are they picking the site because of it's the highest density of lemmings? I don't know the answer, but both of them seem to work in concert here because the owls nest usually on these highest places which have the highest densities of lemmings. All right, and then how do they do with oil and gas exploration? They're fine. If you're not running over the nests with snowmobiles or ATVs or going out there and harassing them like wildlife photographers and some birders, these are some of the most protected sites are in the oil and gas exploration areas because they're off limits, and they're some of our best breeding sites. So they can do really well. They're very, very, very forgiving. This is bad. Ukbiagvik, a place to hunt snowy owls. But this is, in years past here, we would find this, owls just shot and don't know who did it or anything like that, but just shot and left on the tundra. Owls in traps, this happened over in Russia, where they were catching them in wolf traps and selling the eyes on the aphrodisiac market by the hundreds, supposedly. It's all secondhand info. That's the hard part. This was a really bad one. This was the U.S. Fish and Wildlife Service trying to protect Steller's eiders, so they were trapping foxes. They just happened to trap everything else. And we resolved that, though. Somehow this picture got on the internet. I don't know how, but it did. And someone took a picture of it, and then the Fish and Wildlife addressed it. And then why are snowy owls white? This is kind of cool. We published this paper a while ago. This is kind of neat here. And so you don't have to go through that. They're white basically because most of their life is spent in a white environment here. It takes about 4 years to be all white. But what's interesting is that younger males that are spotted and barred that look like females don't breed. They don't get a chance to breed. All right? Only the adult males, it's 4+ years to become bright white, only adult males breed. So basically females, they only select older white males with resources. And that's what's going on here. We have all the data to prove it. And this is what it looks like. Here's your female, and here's your male. All right? And the young males that look like females, kind of like this, they don't have territory. Sometimes they hang out in bachelor pads or by themselves, but it's only the older white males that have a lot of resources that get to breed. It just kind of shows you some cool shots here. Why be that bright white? You know, that's like fluorescent white. And so, again, we had some ideas. First of all, came up, do they reflect in the UV range? You know, like so many things do. And do owls look at each other differently? And so, what we tried to do is we got one fresh killed owl that looked like it died of a heart attack. We have no idea. Anyhow, we got it and we measured it. And we looked at all the places where it reflects, but it never reflected in the UV range. It always reflected very, very bright white on the shoulders. I'll give you a better shot here. And you can see 80% as bright as fresh snow, upper chest, shoulders, back. These are all the areas that the male shows off to the female. So during courtship, the male will go out there and he'll show off his chest, he'll put his wings up, he'll kind of go around like this, show his back, show his brightest parts to her, and then she makes some decision, you know, and I don't know how she makes her decision. If he's got food, then I'll mate with you. And you got food, money in the house, we're in. And other than that, but so they probably don't reflect in the UV range, and actually owls don't have the apparatus to see in the UV. All right, anyway, so fall comes, and this is August. Things are starting to change pretty quick up here. And the females now, they drift away from being, you know, their mom. They start to move off a little bit. Now it appears that they're replenishing their body reserves. They put so much effort into, you know, courtship and then laying the eggs and incubating each egg for 33 days and then sitting on the chicks, each chick for another 21 days or so, and then monitoring them when they're out in the tundra. So they kind of move off a little bit, and the males just continue. They take over the parenting pretty much, and they just grab lemmings and they drop them off to the chicks out in the tundra there. And so we're all used to these eruption migrations, whatever they are, when all these snowy owls show up in the northern tier of the United States, particularly the Great Lakes and Northeast region. We call it an eruption migration. It kind of works, I guess. But why do they do it? You know, and so what does it mean? So anyway, this is, you don't have to read all this, just you know, an act or instance of erupting. But it's interesting when you look at the word from, you know, Merriam-Webster's dictionary, it really doesn't mean what we think it means, except when you get down to the tertiary definitions here, such as a sudden increase in a relative number of animals, or a secondary definition, you know. So it kind of works. And one of the things that we use a lot, like cycles, doesn't really work. Eruptions kind of work. So nonetheless, we're stuck with the word, but I think it can work. And so we've been sticking with it. And then the ecological definitions, you know, are similar, but not exactly what the primary definition of the word eruption is. Nonetheless, some people say that they can age and sex snowy owls in the field. And this is, you know, two snowy owls. I think they're both females. This one might be a first-year bird, but how old is this one? We have no idea. So when you go out there and you say it's a male, it's a female, it's a first year, you can do an adult male probably pretty easily. But doing the others is more difficult. And this is what it looks like. And you know, when we have these eruption migrations, it's the biggest wildlife viewing event in the nation every year. You don't have to be a birder. People come, I mean, you know, the senior centers get busloads of people out there to go see the owls, you know, and school groups go out, and people you would never think that have any interest in nature or wildlife get their families and they go see the great white owl from the north when it has all these eruption migrations. So I'm going to leave you kind of with some cool shots here, and kind of, you know, this is why I keep doing it. And we have 8 or 9 major research projects. This is one of many. But the reasons I keep doing it and I keep being a field researcher, because I never want to just be stuck in an office, it's for reasons of this. This is cool. This is what it's like. Females scream, males respond. thank you very much. I can ask you any questions. Appreciate it.